when we say married couple, it's usually contain a husband and a wife. We're very conservative, so please don't go and argue like why must it be a boy, a woman, and a man. Please don't. There's not a time for you to be hold up to your ideals, please. Okay. So usually it's a man and a wife. But I think recently also they don't really say a married couple. So safe. So anyway, this is like a man and a woman there. So this is grouping. We have 4 boys, 3 girls, and 2 MC. Two person from the married couple lah. Okay, so you want the married couple to sit together. So there are 9 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you want to group them, hear me out very carefully. You group them like that. So when you arrange the rest, right? It's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 entities to arrange. When you permutate this, the whole couple will just move together as an entity. Get it? So this is just 8 factorial for the outer entity, but don't forget the husband and the wife can decide where they want to sit. So we inside the group, there's another permutation. The husband say, "Hey, I want to sit beside here." Then the wife say, "No, I want to sit the other side." So choices, guys, choices. So it's 8 factorial times 2 factorial. Okay. So the part 2 and 3 are essentially the same thing. So you just try and do it first. So this is outer entity permutating. So usually the men and the boys are different. And the woman and the girls are different. So yeah, the boy doesn't include the man. I'm sorry, it's not very clear. So if this question comes at exam, just raise up your hand and ask your teachers. Okay. Oh, if all boys sit next to one another, they have to be one whole group because the boys sit next to one another. All the boys, yeah, actually true. All the boys, sorry. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the boys are 4 of them. 1, 2, 3, 4, 5, 6. 4, 6, 8, 9. So you have 2. So all the boys sit next to one another. So 2, 4, 6. 6 outer entity times 4 factorial. The boys can also multiply by themselves. I mean the arrange by themselves. All the girls sit next to one another. But same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have got girls will be 3 of them. 1, 2, 3, 5, 6. So 3 girls. 1, 2, 3, 4, 5, 6, 7. 7 alternative. Okay, I want to do a part 4. Part 4 is very real. Choosing 2 lampposts to sit between the married couple. Like yep. Okay, part 4 there are 2 methods. Method 1. So you have 9 people. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you 4 people, right? Husband and wife here. Now one thing, one trick is this, guys. You see this is four boys versus 4 girls. How many boys are there? 3 girls versus 2 people who are married. 2 married people. So try not to see as B, V, G, V, M. So because if not, right, you may think that you need to consider 1 boy, 1 girl here, 2 girls and 2 boys. Then you'll be very messy. Then so what you should do is you try and think it as 7 MC M prime versus 2 MC lah. In this case here would be is always to rephrase it, because this trick here is very useful, especially when we do a more complicated question. You realize that you will be you will need to do this kind of thing, like where you group the non-MCs as 1 and 7. Then it's much easier because the whether it's a boy or girl is irrelevant, right? We just want to know who are the two people sitting in between. That's all. So you're right. You need to choose. So 7 choose 2 is definitely one of the thing here, because to choose the 2 lampposts here is 7 choose 2. Okay, 7 choose 2. There's no 5 factorial. Okay. I don't think there's 5 factorial. Okay. Any else to choose? You can choose the other people 5 choose 5, but there's no is not important, right? So 7 choose 2 for the lamppost. Any issues? No. So then we can proceed to permutate the outer entity 1, 2, 3, 4, 5, 6. 6 outer entities. Okay? 6 outer entities. Not any issue. No. Then yes, times 2 factorial, because the lamppost can swap seat and also the married couple can swap seat. So this should be an answer. This is method 1. Okay? Method 2. Okay. Now, one way of doing well for PNC is to learn a lot of methods, because you consider all the methods, right? Actually, I don't even think that these are the only 2, but you can try and think of others, because all these methods are sometimes it's not taught by me. It's like taught by students. And then they ask, how come this one work? Yeah. So later I'll pick it up. So the idea is try and learn, because there are a lot of ways to solve a question, okay? So method 2 is pretty interesting. So I saw these students did this. So what you do is, right, you consider the non-married couple first. So you do this. 1, 2, 3, 4, 5, 6, 7. Any issue with that? 7. Then you arrange them is 7 factorial, right? Then because you want to slot the husband and wife in, right, you consider how many slots you can slot them. So this is 1 slot. Then this is 2 slots. Slot number 2. All right. Then the third slot will be this one. Then the 4th slot is here. Then you have this slot here. Then this slot. How many slots are there? 1. Yeah. So it's 1, 2, 3, 4, 5, 6 slots. So essentially, you can also get the answer by multiply 7. There are six ways to slot husband and wife. But is that the 6 slots? Is this the answer? Times 2 factorial. Husband and wife can swap seat. Permutate them. So these are the two ways of solving it. Pretty cool. So if you do use method 1 to solve, you at least learn method 2. If you use method 2 to solve, learn method 1. If you don't even know how to solve, then just copy both methods. Just learn both.